The shape of thought: why neural geometry just became Wall Street's next competitive moat. The consensus read is already outdated. What matters now is the second-order effect most commentary still ignores. We will map trigger, incentive shift, and downstream impact before the close. Renaissance Technologies posted openings for geometric deep learning researchers at $800K plus compensation. But here's what nobody's talking about: they're not hiring these people to build better models. They're hiring them because neural networks encode meaning through geometric structures, and understanding those structures is about to become the highest leverage competitive advantage in AI. Last week, DeepMind, Stanford, and Anthropic published converging research on the same insight: semantic relationships in large language models aren't random. They're organized. When you plot out what a model knows about concepts like king, man, woman, and queen, they form measurable geometric shapes, manifolds, in high-dimensional space. Distance and curvature in those spaces encode meaning. Think of it like discovering that what looked like noise on an oscilloscope is actually sheet music written in 1024 dimensions. Here's where it gets real. MIT's CSAIL lab just proved you can measure the Ricci curvature of these manifolds to predict which concepts a model will confuse under adversarial attack with 89% accuracy, without actually running the attack. The old way? Exhaustive testing. The new way? One geometric analysis of the model's weights. For enterprises spending $2 to $8 million annually on AI safety testing, this is a 70 to 90% cost reduction with better coverage. But that's just the compliance angle. The real competitive restructuring is happening deeper. The EU AI Act and the proposed US AI Safety Institute standards both require transparency documentation. Current methods, saliency maps, attention visualizations, are expensive theater. They show what the model attended to, not why it reached a conclusion. Geometric analysis offers something unprecedented: a mathematical certificate of reasoning structure. Anthropic's latest technical report shows their constitutional AI training creates measurable ethical submanifolds, regions of latent space with specific curvature signatures that correlate with safe outputs. Firms that can generate geometric compliance certificates will clear regulatory review in 4 to 6 weeks instead of 6 to 9 months. In healthcare AI and financial services, that timeline compression is worth $50 to $200 million in accelerated revenue capture. Tempus AI, the cancer genomics company, just announced a partnership with geometric ML startup Manifold Labs to create topological safety proofs for their diagnostic models. Expected FDA review acceleration: 5 months. This is happening in real time, right now, and most competitors have no idea it's coming. Here's the structural advantage: the people who understand differential geometry and algebraic topology spent 2 decades in pure mathematics departments, far from machine learning. The people who built transformers came through CS programs that barely touched Riemannian manifolds. This skills mismatch creates a 12 to 24-month talent arbitrage window. Companies hiring mathematicians with topology PhDs and retraining them on neural networks are accessing world-class geometric intuition at $180,000 to $250,000 base, a fraction of what elite ML researchers command. Citadel's quantitative research division just launched an applied topology fellowship, 6-month rotations paying $200,000 for mathematicians to work on geometric model analysis for trading systems. But there's a second layer to this that's even more valuable. If meaning has a geometric structure, you can perform surgical edits in latent space that modify one concept without distorting neighboring regions. Stanford's May preprint demonstrates 10x more stable fine-tuning using Riemannian optimization on the model's intrinsic geometry. For enterprises running proprietary models, Bloomberg's Finance GPT. Harvey's Legal AI. This transforms the entire economics of model maintenance. Current approach: maintain 5 to 10 specialized model versions at $2 to $5 million training cost each. Geometric approach: maintain one model and perform targeted geometric edits at roughly $50,000 per update. This means monthly model updates instead of annual retraining cycles. AI shifts from CapEx to OpEx. Unit economics improve dramatically. This is the move that separates companies that will dominate AI deployment from those that will stay stuck in the old paradigm. The market is already pricing this in. Cerebras, the wafer-scale AI chipmaker, increased their private valuation 40% in their Series F extension, driven specifically by their geometric computing roadmap. They're betting the next model paradigm leans into explicit geometric inductive biases. Geometry-optimized inference could achieve 3 to 5 times better efficiency for the same workload. That's a CUDA moment. That locks in developers for a decade. Here's the timeline that matters. By Q4 2026, every major AI lab will have geometric analysis in their standard toolkit. The advantage goes to those moving now.